Hello, welcome to this webinar on specifying LED Troffers or retrofit kits. And this talk is specifically about replacing existing fluorescent Troffers. This presentation is coming to you from the Lighting Research Center at Rensselaer Polytechnic Institute in Troy, New York. We were founded in 1988 and we occupy a historical building in downtown Troy. We have about 35 faculty and staff and about 10 to 15 graduate students at any one point in time. And we're running about 40 to 60 concurrent projects, and those are taking place both in the field and in our laboratories. Today's presentation is sponsored by the Lighting Energy Alliance. This is a membership-based alliance, and the charter members are Efficiency Vermont, Energize Connecticut, and National Grid. This start of the webinar was actually re-recorded due to a technical glitch, and now we're going to switch back to the original recording, and so you're going to hear a change in the audio and see a difference in the slides.
All right, I'd just like to give a heads up of what we're talking about today. We're talking about a one-for-one replacement for fluorescent Troffers. So we're not going to be getting into doing new lighting designs. If the existing Troffer installation was working for the occupants, then you should be able to find LED Troffers that will also work. We did not test products for this study or for this project, unlike many other projects that we run here. We're relying on manufacturers' supplied data, and the focus here is on the specifying process. So if you are very well versed in specifying light fixtures, if you're a lighting engineer, lighting designer, I will not be insulted at all if you'd like to drop out, because this is basically a presentation on specifying Troffers that will meet illuminance and occupant satisfaction requirements. We're focusing here on LED Troffers in retrofit kits. We're not going to be talking about LED tubular lamps, except for the next slide. We're going to talk about some pros and cons. However, at any point, both I and the Energy Alliance sponsors are very interested in hearing what product categories you would like to know more about. So please, we'd welcome that feedback. As we go, please keep in mind that we're not recommending for or against any particular products. We're just talking about evaluating products and putting them to their best use. And also, finally, this presentation is really an expansion of a brief PDF document that you can find online at the URL that's shown at the bottom here. So that's a good summary to take away from this presentation at the end. All right, so when you're switching out or upgrading a fluorescent Troffer, you essentially have four options to choose from. You can go with a new LED Troffer Luminaire, a complete package. And the benefit there is that because the manufacturer designed the whole system, they can control the intensity distribution, the light output, the power electronics, so the driver is designed for the complete system. Because everything was fit together in the design process, there's a potential for better thermal management, so the heat generated by the LEDs can be shunted out to the plenum or to the room. And as you may be aware, heat management is a very important issue for LEDs. Some of the downsides for using a complete luminaire is that they can be more expensive than other options, and you do have to work above the ceiling level. So if there are any issues with that, such as accessing above the ceiling, that might not be the best option. Another choice to consider is a retrofit kit that completely replaces the optics. So this might snap in, might include a reflector, a new lens or diffuser that would replace the existing one. And here, because again, the manufacturer is controlling the intensity distribution, controlling all the optics, and they're supplying all the power electronics along with the LEDs, they have complete control over the design. So that's a benefit. And also, you're going to be working completely below the ceiling level. So you have that benefit as well. There are other retrofit kits that do not include the optics. They still have the benefit that the driver was designed for the system and you're working below the ceiling. However, because you're relying on the existing optics, the intensity distribution is not known, and also, especially if it's going through an existing lens or diffuser that's perhaps degraded over the years, you really don't know the light distribution or the light production, the light output. And then the lowest cost option may be a tubular LED lamp replacement. And again, of course, you'd be working completely below the ceiling level. However, there are a lot of considerations that you should really be wary of. You don't know the final intensity distribution, again, if it's relying on the existing optics at all. Again, you might suffer from optical material degradation. But also, you don't know the age and compatibility of the existing ballast. So some of these TLEDs rely on the existing fluorescent ballast for their power. And if the ballast is not completely compatible with the lamp itself, you can run into both short-term compatibility issues where you're not getting the performance you expected, and long-term compatibility issues which could potentially shorten the life of the ballast or lamp or both. Also, these fluorescent ballasts have a finite lifetime, typically between 50 and 100,000 hours. And if it's already been installed and used for 10 or more years, it's possible that it could be reaching the end of its lifetime and reach failure before the LED product is reaching its failure point. Okay, and then another issue is that some of these TLEDs do not use the ballast, but require bypassing the ballast and putting line voltage into the tombstones. And that could create a safety hazard if at a later date the LED product fails and somebody goes to put a traditional fluorescent tube into the fixture, and they're not aware of it. There's supposed to be a sticker on it, but they might not see it or it might fall off. And finally, if the tubular LED is putting all of the light production into a thin strip, necessarily because that's the only place that they can put the LED sources, that's going to result in a higher intensity light source, which it creates the potential for glare. So those are the pros and cons for the different options you have for upgrading a fluorescent troffer. And today, moving forward, we're just going to be talking about the two on the far left, the Luminaire, a complete Luminaire or a retrofit kit that includes the optics so that you know the intensity distribution and the light output from the product. All right, so now we're going to go through a series of steps that will help you identify LED troffers that should satisfy the occupants and save energy. And the first step is to identify your target illuminance level. And first of all, what is illuminance? So lumens is the measure of the light output from the troffer. And illuminance is the amount of light that is falling onto a surface in terms of lumens per square foot or per square meter. And the unit for that is lux or foot candles. And I would argue that that when you're doing a retrofit of fluorescent troffers, your primary job number one, is to provide adequate illuminance. An analogy might be if you're doing, say, an insulation upgrade, or say replacing a boiler or furnace with a more efficient model, but at the same time you're putting in a new thermostat, but when you put that in, you're lowering the temperature set point quite a bit, and you're leaving the occupants freezing throughout the winter. They're all bundling up. Well, you can show that you've got energy savings, but were you really being fair to the occupants? So to do a true quality retrofit, you need to provide adequate illuminance. And there's two ways to set the target illuminance that you should be looking for. One is to go by the recommendations of the Illuminating Engineering Society of North America, or IES. And another option is just to agree to a target illuminance level with the occupant before you do the installation. So the first method is to look at a recommended level from the IES. And these are published in the Lighting Handbook, which is currently in the 10th edition. And they have hundreds of different space types. So they provide illuminance recommendations based on how the space is going to be used. For an office environment where Troffers are typically used, the illuminance recommendations are typically in the 10 to 50 foot candle range. But they also, and that's for the horizontal illuminance on, say, the desk, which is the work plane. They also provide recommendations for the vertical illuminance for the walls and the uniformity ratios so you don't get hot spots or dark areas. If you don't have access to the IES handbook, a rule of thumb for offices is about 30 foot candles or 320 lux. And that's the average across the whole room for the horizontal work plane. So now we're looking at just a scan of a sample page from the IES handbook. And if you look down towards the bottom of the page, you can see the 300 lux recommendation. And if you look over what that is applying to is an office environment where the middle-aged occupants are reading print on a page that's at a 10-point font. So that sort of brings up another topic, which is, well, what if you are not actually lighting for people who are reading 10-point font all day? For example, if you've got a room full of people who are using, say, self-luminous computer screens, perhaps that's a source of energy savings because you could appropriately target a lower illuminance level that would still be useful for the occupants. So the other way to find a target illuminance level is to agree to a light level. So for example, what you could do is before you start the retrofit project, go in and measure only the electric lighting. So this would be at night or with the opaque shades drawn, and use a calibrated illuminance meter, such as the one that we're showing here, and then calculate the average illuminance across all the desks. And if you find that this illuminance level, oh, I'm sorry, I did not advance this. Apologize. All right. So, as we were saying, so this is a picture of a calibrated illuminance meter that you could use to make measurements. And if you find that the illuminance level in this room is lower than the IES recommendations, but the occupants are still happy with it, then you can agree that this is going to be your target illuminance level. So that can be another source of energy savings if you find a lower light level that you're happy with. Now, when we talk about these target illuminance levels, what we're talking about is the maintained illuminance, not the initial illuminance. And the reason that they're different is that the light output from the luminaires is going to drop over time, and for two reasons. The first is luminaire dirt depreciation. Dirt is going to build up on these fixtures and block some of the light. And the other is lamp lumen depreciation. And the reason is that all light sources, the light output is going to go down over time. And we're going to talk about both of these. So first, the dirt depreciation factor. I've heard many times that you do not need to account for this with LEDs, especially sealed LED Troffers or products, because they're not going to get dirty. But the fact is that even when they're sealed, really there's still enough of a gap for air to enter and exit. So as the light gets turned on, it heats up, and when it gets turned off and it cools down, that heating and cooling cycle is going to force air in and out of the troffer volume and bring dust with it, which is going to settle on the optics. So how much is the dirt going to decrease light over time? It depends on a few factors. Primarily, in an office environment, it's going to depend on the time in between cleanings. So here on this page, on this slide, we're showing a graph from the lighting handbook. And if you look at the red line on the top, this is showing for a clean environment and a direct downlight, so that would be applicable to an LED troffer. And if you plan on cleaning these LED fixtures every 2 years, you find that you'd have a Luminaire dirt depreciation factor of about 0.91. So that would mean that you take the initial luminous flux, or the lumens from the troffer, and multiply by 0.91 to get the maintained lumens due to dirt depreciation. The other reason that the light goes down is because of the lamp lumen depreciation. Here we have a graph showing the lumen depreciation for various fluorescent sources. And what you're looking for is the maintained light put, which is considered to be the light output at half the the midpoint in the life of the luminaire, or the light source in the case of fluorescent. The thing is that there's no one graph that can show you the lamp lumen depreciation for LEDs, and the reason is because different LED manufacturers or different LED products have a different sort of curve as they decline in light output, and also they have different lifetimes. So we suggest that you go to the manufacturer for their recommended lamp lumen depreciation factor. We're listing two here. Acuity Peerless is recommending 0.87. Philips Lumic was recommending 0.85. I believe Cree is a little bit higher. So what you would do is then take the initial lumens, the rated lumens from the luminaire, and for example, say it's 4,000 lumens, and you're going to multiply that by the luminaire dirt depreciation factor, and then multiply that by the lamp lumen depreciation. And you'd find that initially a 4,000 lumen troffer is going to have a maintained light output of 3,130 lumens. So going forward in this talk, when we're talking about illuminance levels, we're talking about this maintained illuminance level. Now, one word of quick caution, we're talking about photopic illuminance. So this would be the standard 30-foot candles that the IES speaks to. There have been some claims over the years that perhaps LED products, especially if you use a higher correlated color temperature, do not need as high of an illuminance level, but we would caution against going by that and sticking to the photopic illuminance level because those claims are typically not appropriate for the office environment. However, one strategy for reducing illuminance levels or average illuminance levels that actually is a very good idea, and we recommend looking into this, is called task ambient lighting, or sometimes task vertical ambient lighting. And the reason for this is that when we're talking about before how somebody needs a 30-foot candle illuminance level to read 10-point font, well, they need that right where they're going to be reading, such as right at their desk. They don't necessarily need that in the aisles between the cubicles or on the sides of the room or over shelving, all those kinds of things. So what this strategy is to reduce this overall ambient illumination and then add task lights at the desks or under cabinet lights at the desks to bring up the illuminance level on those surfaces where the work is being done. You also want to add some, say, wall washers or other light sources to put some illuminance on the walls. And the reason for all that is that you don't want people to feel like they're working, say, in a dark cave. You want it to still be an aesthetically pleasing place. So that's why you don't want to lower the ambient illumination too much, and you want to also provide some vertical illumination. The company FineLight did a study with the California Lighting Technology Center and found energy savings in the range of 28 to 59%. And you can read about that at the URL at the bottom of the screen. We would suggest that for the first couple of times that you provide task vertical ambient lighting, you might want to work with a lighting designer or engineer. And the reason for this is you just want to make sure that you're getting those uniformities right and you're providing enough illuminance on the various surfaces so you're still getting a pleasing lighting in the room. All right, so we have now figured out what our target maintained illuminance level is going to be for this room. So now we need to find some LED luminaires that are going to provide that level. We have two recommended methods for finding these Troffers. The first one is using Photometric software, and the second is finding the maintained light output from the existing fluorescent Troffers, and then matching that with the new LED Troffer. We do not recommend just estimating the light output just by looking at what type of luminaire it is, and we'll talk about the reason for that. So there's different photometric software packages that will work. Here at the LRC, we typically use AGI 32. There's also Visual, Dialux, and others, and they all work well. Who would be doing this modeling? Sometimes manufacturers are willing to do this. They have application engineers whose job it is to do photometric modeling. Manufacturer reps may be able to do it for you. You could contract with a lighting engineer or lighting designer, or you could train somebody in your own office to run the software. What you're going to do is actually relatively simple. You're going to give somebody the room dimensions. So you'd use, say, a handheld rangefinder to get that very quickly. The number of luminaires, if they're spaced evenly throughout the room, probably just the number of luminaires is sufficient. You probably don't have to measure out the locations. If there's any tall furniture, such as cubicle partitions or bookcases that could possibly create shadows, you're going to want to let them know the dimensions and locations of those. Tell them the target illuminance that we were just talking about before that you're trying to hit. The lamp lumen depreciation and luminaire dirt depreciation that we talked about. The luminaire models, of course, that you're considering. You can't run the software for an infinite number of different luminaires. The software is going to assume that the ceiling has a reflectance of 80%, the walls 50%, and the floor is 20%. If you notice something unusual, like very dark painted walls or, say, a very light colored wood floor, you're going to want to let the person doing the model know that so they can correct those reflectances. And also what your acceptable average to minimum uniformity ratio is. And in an office environment, typically 5 to 1 is appropriate for the maximum that you'd want to hit there. So here's an example. We're modeling a 60 by 40 foot room with a 10-foot ceiling, so it's 2,400 square feet, and it's a model of this room is shown at the top right here. It's filled with cubicles. The cubicles have 4-foot high walls. Each cubicle has a desk, a low cabinet, and then an upper shelf. And it's lighted by 24 fluorescent Troffers that are 2 by 4. They each have 2 T8 lamps in them, and each Troffer has a power demand of 56 watts. And when we run the software, we get the results at the bottom. This is a pseudo-color image showing illuminance looking down from the ceiling onto the room. And we find that the average work plane illuminance is 30 foot candles. We're hitting that target that we had before. The black outlined boxes or rectangles that you see, those are the locations of the luminaires, the Troffers. The red stripes that you see, those are the tops of the shelves. And the reason that those are higher illuminance is because they're closer to the luminaires. But you can see that over the rest of the space, the work plane illuminance is varying, but it's within that 5-to-1 ratio, but it's averaging 30-foot candles. So now we identify an LED troffer. We're going to call this Model A. All the troffer examples that we're giving here are actual troffers that are popular within the incentive programs of the Energy Alliance members. So these are real examples. So this one had an initial lumen output of 4,000 lumens. Maintained, it has an output of 3,130 lumens, as from the previous example. And running it through the software, we find that the average illuminance is 25 foot candles, which is lower than our target. So we wanted to provide this as a caution that that many of the troffers that we saw were popular in these programs have a very similar light output. And so that really needs to be considered whether or not they're providing adequate illuminance or maintained illuminance for those rooms. And the second caution is that what we're doing in this example is we're replacing a two-lamp fluorescent troffer. Well, many fluorescent troffers are 3 or 4 lamp troffers. So this sort of lower light, or this light output level is probably not going to be adequate for those, or definitely is not going to be adequate for those types of troffers. So we say troffer A is not going to work, so we go to a higher light output troffer with 5,000 lumens maintained. We run it through the model, and we find 42 foot candles, so it's well above our target illuminance level. And we say, well, at least it's going to leave the occupants happy with getting enough light. It's probably not going to save very much energy, if at all. And we're going to look at in some future slides about how to better save energy. But we're going to leave that example right there for 1 sec, and we're going to switch over to the other method that we talked about for identifying an LED troffer. So what you have to do for this is you have to get up on a ladder, go above the ceiling level, find the model of the luminaire, the model of the ballast, and the model of the lamp. Then you have to find the spec sheets for all of these. And off the spec sheet, you have to find the optical efficiency of the luminaire, the ballast factor of the ballast, and the light output of the lamps. And then what you're going to do is find the maintained light output by taking the total number of lamp lumens, considering how many lamps are in the fixture, multiply that by the ballast factor, multiply that by the optical efficiency. The optical efficiency, by the way, is the amount of light is getting out of the troffer versus how much light was produced by the lamps themselves. And you're going to multiply that by the dirt depreciation factor and then the lamp lumen depreciation factor. And here we have to use the fluorescent one shown in this graph. And then you're going to have the maintained light output from that fixture, and you're going to find an LED troffer that provides at least this many lumens maintained. And assuming that the intensity distribution is similar between the LED troffer and the fluorescent troffer, you're probably going to be have a pretty similar average illuminance level. So I can hear everyone thinking to themselves that this is a lot of work, and I'm probably not going to be able to find very many of these spec sheets or cut sheets anyway for these older fixtures. I would really, what I'd like to do is just to walk into the room and look at the fixture type and just say, for this type of fixture, and perhaps for this lamp that's installed, I have an estimate for the light output. And the issue with doing that is that the US DOE did a study and found that there's actually quite a wide range of optical efficiencies even within different troffer types. So for example, for a lens troffer, they found optical efficiencies from 64% to 89%, and you're not going to know from looking at it what the efficiency is for the troffer you have. And also we know that ballast factors are low, normal, or high. So as an example, even if you know that you have a particular T8 lamp in a lens troffer, if you have one of these Troffers that happens to have the 64% optical efficiency and is at a 0.7 ballast factor, and then another one, say in another room that has 89% optical efficiency and a 1.2 ballast factor, the one with the higher efficiency and high ballast factor is going to have 140% more light output than the lower light output one. And that's just too wide of a range. You just can't be certain that you're providing enough light for the occupants based on just looking at the Troffer. All right, so we've talked about finding your target maintained illuminance level and how to find a Troffer, an LED Troffer that's at least going to hit that maintained level. Now let's talk about saving some energy. First, getting back to that example, we want to avoid overlighting. We want to hit the target illuminance level, but we don't want to go too far over it. And just by plugging in various Troffers into that model that we showed before with the Photometric software, we found that just by increasing the illuminance level by 5 foot candles, increased the lighting power in the room by 15%, and that's averaged over a number of different Troffers. So in some cases, your best strategy might actually be to go with a lower efficacy Troffer that is closer to the providing the target illuminance level rather than a higher efficiency. So continuing with our example, we saw that very high light output LED Troffer B. So now we go back to the catalogs and find LED Troffer C. And this one has a maintained light output of 3,730 lumens, and we're maintaining 32-foot candles, which is relatively close to the target of 30-foot candles. And we can see now, if we had gone with B, we would have actually increased the power demand in the room. But now if we go with C instead, we can actually decrease the power demand of the lighting in this room by about 24%. Another strategy for reducing energy is to use a high efficacy Troffer. So what efficacy is the lumens coming out of the fixture divided by the watts going into the fixture. And we, again, looking at a number of different Troffers for that one room, we found that if you had one Troffer that was 15 lumens per watt greater efficacy than another Troffer, you could reduce the power demand by about 20% in that office. And again, that's not for any one or two particular Troffers, that's an average over a number of them. But it points to the importance of finding a high efficacy Troffer. One tool that you can use to identify high efficacy Troffers is the DLC qualified product list, Design Lights Consortium qualified products list. On their website, you can set a criteria range that you're looking for. You can set the luminous flux, the CCT, all that other stuff that you're looking for, and tell it that you're looking for 2x4 Troffers. And then it'll filter out and just give you all the Troffers that meet that criteria. And then you can download it as an Excel spreadsheet and then sort by efficacy. And you could look at the highest efficacy Troffers there and see if they meet your requirements. So following this strategy, we just shifted LED C, Troffer C, over to the left there. And we found another Troffer, LED D, from the catalogs. And where C had an efficacy of 85 lumens per watt, D has 93 lumens per watt. And so we've reduced the power demand for the room by about 9.4% because the luminous efficacy went up by 8 lumens per watt. So that's a pretty substantial energy savings right there. Another consideration for energy savings is the programmable driver. This is some types of drivers, LED drivers that are available can actually be set to a certain light output wirelessly even after installation. So one way you could do that is, for example, if you're using a troffer that's a little bit too far above the target illuminance level, you can actually reset it in the field, or set it in the field to bring down the light output, so you're going to eventually achieve the maintained target illuminance level. All right, so now we found some troffers that meet the target illuminance level and save energy, but we also have to be sure that the occupants living with these troffers are going to be happy. So how do we do that? One of the first considerations is the correlated color temperature, or CCT. Typically in an office environment, this ranges from 3,000 Kelvin to 4,000 Kelvin. And what this is talking about whether the light has that warm, orangish hue, which is the lower CCT, versus the high CCT, which has the bluish, cold look to it. There isn't any one best CCT. It's really occupant satisfaction. If they're happy with what they have now, you can just plan to match that with the new troffers. The one caution we have is that all of the troffers in one space should have the same CCT, and the reason for that is that if they don't, some of them are going to sort of stick out, so it's aesthetically displeasing. And as we mentioned before, if you go to higher CCTs, they can provide a perception of greater brightness, but if that occupant is at their desk trying to read say 10-point font on a piece of paper, and you've now reduced the illuminance level by increasing the, and also increased the CCT, so they think they have the same brightness, they're not going to be able to read as well as before, because that visual performance is based on the illuminance, not on the brightness percent. There are a number of other metrics that are important to occupant satisfaction, and unfortunately many of these are not really measured or reported along with troffers. So your best bet is probably going to be to install a sample troffer in the space and evaluate it along with the occupant. And here's some things that you should look at. One is the glare from the troffer. And you want to be sure to check this from a lot of different positions within the room, because it's going to change based on angle. Color rendering, we've all heard of color rendering index, or CRI. That one is reported, and pretty much anything on the DLC QPL is going to have to have a CRI of 80 or above, which is acceptable for an office. In addition to that, there's also how saturated colors look from this light source. So that's how punchy or full the colors look. And then also tint, which is you don't want the lighting to create, say, a green cast on the room. If the lighting is going to be on a dimmer, you need to test it with that dimmer. And also, although there are metrics for measuring flicker, they're typically not readily reported. You might be able to ask the manufacturer for this, but you can also evaluate it yourself. What you could do is go to, say, daylight, wave your hand or a ruler or a pencil, and look at how your hand looks as you wave it, and then go back underneath this light source and do the same thing and see if you're noticing flicker. And if you are if this is on a dimmer, you're going to want to evaluate the flicker while it's dimmed in addition to the full light output. All right, so now we've found troffers that meet all the requirements and satisfy the occupants. Now let's see if it makes business sense. So we're going to look at some economic calculations. In this series, we're just focusing on the payback period, which is the cost of the installation divided by the annual operating cost savings. Shown here is a sort of rearrangement of the terms. So what you can do is plug in your desired target payback period of, for 5 years is a typical target. And then you can find from this equation how many watts do you need to bring each troffer down by with your replacement, by going from fluorescent to LED in order to hit that target payback period. One thing that we have to caution you is when we're calculating for the annual operating cost savings, Primarily, that's going to be from the energy savings from using LEDs. There can possibly also be maintenance savings, but not necessarily, and you need to think about this before using a calculation. One reason for that is that some long-life fluorescent lamps actually can last as long or longer than an LED troffer can. So if these have been installed, you're not going to be saving money from avoiding lamp replacements. And also, as we talked about before, LED troffers are susceptible to dirt depreciation. And so if you're going to count on a maintained illuminance level of a certain amount based on a cleaning, say, every 2 years or so, that maintenance is going to have to be performed even on LED troffer. And typically with the fluorescent troffers, that was performed along with the relamping, but that would not be the case for the LED troffers. So without further investigation, you can't assume that the LED troffer is going to have a lower maintenance cost. So let's go to an example. Say the operating time for this office is 3,830 hours per year. And say the price of the Luminaire LED-D is $140 each. It costs $40 each to install them, and you get a rebate of $50 per troffer. And you find that the lamp life that's for the fluorescent lamp that's installed is 30,000 hours, and estimating, say, from RS means, the relamping cost per troffer is $30. So the total cost of the installation would be $3,120. The annual energy cost savings would be $247 per year. And the, but say that we do plan on avoiding relamping costs, you'd be avoiding $92 per year. We did not add in anything for cleaning the LED troffers. Perhaps that could be done by the building maintenance staff, so it would not be included in the lighting budget. So using those factors, you would get a simple payback period of 9.2 years. That might be longer than a typical business is looking for. So one consideration is that if you're replacing a T12 troffer rather than a T8 troffer, that would be a much shorter payback period. And also, if you get an incentive from your program of $100 instead of $50, that would bring your payback period down to 5.5 years. All right, and then also in terms of financial risk, we recommend getting a warranty on the troffers that are at least as long as the payback period. And you need to be careful of what the warranty covers, not just, the troffer stops working. Over time, there could be color shift that becomes unacceptable. The light output could go too low too early. Also, the power electronics may fail before the LEDs fail, so that should be covered as well. And you also need to consider what actually is warranted. For example, if a large number of fixtures need to be replaced, who's going to be paying for that? Is that cost covered or not? And another consideration is whether the LED troffer has a replaceable, allows components to be replaced if they fail, or do you need to replace, say, the whole troffer if the components are inaccessible? So for example, if the driver fails, can you replace just the driver? And then just sort of as an addendum, we would recommend considering lighting controls as another way of saving energy. Some of the newer lighting controls can be integrated right into the Luminaire, so and that's done at the factory. So when you receive the troffer and install it, the sensors and the controls are already installed. Or you can use the more traditional whole room controls. And you would consider both photosensors and occupancy sensors. And hopefully you'd avoid the situation shown at the bottom right where you have an overlit, empty conference room. We don't really have time in this presentation to go into much more detail than that. So I just wanted to point you to some resources. Tomorrow afternoon, my colleague here at the LRC, Leora Radetsky, is giving a webinar on easily commissioned controls. So those are the ones that should theoretically work straight out of the box. And you can follow the link shown here and to attend that. And then I'm also giving the link to 3 reports from the National Lighting Product Information Program that tell you about wireless lighting controls, photosensors, and occupancy. So what I'm going to do now is unmute the phones and invite questions. So hold on one sec, please.
The conference is now in talk mode.
All right. Does anyone have any questions about what we just spoke about? You're welcome to either speak on the phone or type into the chat feature on the screen. Oh, all right, we've got somebody typing. Okay, we have a question about the Photometric software. And the question is open source software. So the one that we talked about using here at the LRC, AGI32, is not open source. You would need to purchase a license for it. And I understand the retail cost for that is about $900. I'm not sure if any of the other photometric packages are open source or not. You'd have to look into them. I'm not aware of any that are. All right, and one question was, can you provide the names of the software that we spoke about? The 3 that we mentioned here were AGI32, Visual, and Dialux. And also, my email is on this screen right now, and I invite you to email me, and I would be happy to send you a PDF of all the slides so you can review these materials. All right. We'll just wait another minute if anyone else is typing. If anyone else has any questions, I'd welcome them, or else we will just thank you for attending. All right, so I think we're going to wrap up. I would once again like to thank the sponsors. We have Efficiency Vermont, Energize Connecticut, and National Grid sponsoring the Lighting Energy Alliance, which sponsored this webinar today. Again, please feel free to email me at snydej7@rpi.edu if you'd like a PDF of these slides, or if you'd like documentation that you attended this webinar for submitting for so thank you very much for attending. We're going to end the meeting now.